Hi everyone, welcome back to the channel. This is another video in the Transient series. In the last two videos, I have solved the problems of RL series circuit, and before that, I had discussed the basic concepts that how to analyze the circuits during switching. In that case, we had seen that the capacitor has property that it opposes the instantaneous change in voltage. That's why we need to express the voltage as a function of time, and that we can calculate by using formula that Vct is equal to Vc infinity plus Vc0 minus Vc infinity into e raised to power minus t by tau, where Vc0 is the initial voltage across the capacitor, that is at the instant of switching. Vc infinity is the voltage across the capacitor once the steady state conditions have been reached after switching, and tau is the time constant, and this tau for RC circuit is calculated by R equivalent into C, where R equivalent is the equivalent resistance seen from the capacitor terminals. Now how to analyze the series circuits during transition from one state to another state, that I will illustrate over here with the help of three different problems. Let's start with the first problem. First problem is the switch in the network shown below is closed at t equal to 0. Determine the voltage across the capacitor. The circuit consists of a voltage source, in series with a resistance. We have another resistance of 10 ohm over here, and a capacitor is connected in parallel with this resistance. Capacitor is of value 2 farad. This switch is closed at t equal to 0, and we need to find out the voltage across the capacitor. Let's say this is Vc. Now we need to calculate the voltage across capacitor before switching. Again, we will have three steps. We have to analyze the circuit before switching. So before switching, what we have? We have 10 ohm resistance, 10 ohm resistance, capacitor, and the circuit is open. Since we don't have any source connected to this parallel combination of resistance and capacitor, so the initial voltage across the capacitor is actually 0. So that, which is same as before switching and just after the switching. Next step is we need to calculate that what is the voltage across the capacitor after closing the switch and when the steady state conditions have been achieved. So after switching, what we have in the circuit, the switch is closed, 10 ohm resistance, 10 ohm resistance, and here we have 10 volt source, and this capacitor will behave as open circuit once the steady state condition have been reached, and there we calculate Vc infinity. Now this 10 volt source will actually get divided across these two resistances since they are connected in series. So whatever the voltage is there across this 10 ohm resistance, that is the voltage across capacitor. So we can calculate the voltage across this 10 ohm resistance by voltage division rule, and Vc infinity will be equal to 10 into 10 supply voltage into the resistance across which we are finding the voltage, and in denominator we have sum of two resistances, so it is actually 5 volts Vc infinity. Then next step is we have to calculate the time constant. Now for time constant we have to draw the circuit again. 10 ohm resistance, 10 ohm resistance. Here we have capacitor terminals. The voltage source has to be replaced by short circuit, and we will calculate that what is the equivalent resistance from the seen from the capacitor terminals. Now, as seen from the capacitor terminals, both 10 ohm resistances they are in parallel. So equivalent of these two is 5, and tau, the time constant, which is R equivalent into C, is 5 into 2, 10 seconds. Now let's substitute all these values in the expression of voltage across the capacitor. Now what's that expression? That VCT is equal to Vc infinity plus Vc0 minus Vc infinity into e raised to power minus t by tau. Vc infinity is 5, Vc0 is 0 minus 5 into e raised to power minus t by 10, or it's 1 5 into 1 minus e raised to power minus zero point 0.1 t volts. So this was a simple sort of problem where we had two resistances connected in series, and we had simple voltage division rule applied to calculate the voltage across the capacitor. Now next problem is, in the network the switch is closed for a long time, and at t equal to 0 the switch is opened. Determine the current through the capacitor for t greater than 0. And this is the switch which is opened at t equal to 0. Point 0.5 farad capacitor, and one more resistance over here. Again it's of 1 ohm. We need to calculate the current through the capacitor. Now when we have to find out the current through capacitor, firstly we will find out the expression of voltage across the capacitor, and then we will find out the current. If the current is denoted by I, then I is equal to C dVc by dt, and we expression for obtaining Vc is same, that Vct is equal to Vc infinity plus Vc0 minus Vc infinity into e raised to power minus t by tau. So again we need to do the calculations for voltage across the capacitor before switching, after switching, and for time constant. Before switching, now what was there before switching? The switch was closed for long time. 2 ampere, the switch was closed. How the capacitor behaves? The capacitor will behave as open circuit, 1 ohm, 1 ohm. Since this is a short circuit, whole of the current will flow through this only. Whatever the voltage is there across this short circuit, same is the voltage across the capacitor. Since there is no drop across this 1 ohm resistance because of opening, and also since it's a short circuit, so voltage across the capacitor is zero. Voltage across the short circuit is always zero. So VC 0 minus or VC 0, both are actually zero. Just before the switching, at the instant of switching, voltage across the capacitor is zero. And then we have after switching case. Now in after switching, the switch is opened. The switch is now open. Here we have capacitor, 1 ohm resistance, in 1 ohm resistance. So once the steady state condition have been reached, so capacitor will behave as open circuit. We need to find out the voltage across this capacitor. The current through this 1 ohm resistance is 0 since it's an open circuit. So whole this of this 2 ampere is flowing through this 1 ohm resistance, and the voltage which is there across this 1 ohm resistance same is the voltage across the capacitor terminals. So what is the voltage across this 1 ohm resistance? It is 2 into 1. So VC infinity is 2 volts. That is same as the voltage across this resistance. So VC infinity is 2 volts. And next step is we have to calculate time constant. For time constant, current source has to be replaced by open circuit. Switch is already open. These are the capacitor terminals. Here we have 1 ohm resistance, another 1 ohm resistance over here, and we need to find out R equivalent over here. So R equivalent is 1 plus 1. Both resistances, they are connected in series. So R equivalent is 2 ohm. Tau, which is R equivalent into C, the value of C was 0.5 farad. 2 into 0.5, it's 1 second. So VCT is equal to V infinity. V infinity is 2 plus VC 0 was 0 minus 2 into e raised to power minus t by tau, which is 1. It's 2 into 1 minus e raised to power minus t volts. This is a voltage across a capacitor. What the question was, we need to find out the current through the capacitor for t greater than 0. So I is C dVc by dt. C is 0.5 t by dt of 2 1 minus e raised to power minus t. 0.5 into 2, differentiation of this part is 0 minus differentiation of e raised to power t is minus of minus 1 into e raised to power minus t. So current through the capacitor is e raised to power minus t amperes. So this is how we find out the current. If we have RC series circuit, we have to first find out the voltage and then we need to calculate the current. Next problem is in the network of figure, the switch is moved from A to B at t equal to 0. Find Vt for t greater than 0. We have two positions A and B, and the switch is moved from A to B at t equal to 0. So this is voltage Vt. 1 farad capacitor and 2 ohm resistance, they are connected in parallel. So whatever the voltage is there across the capacitor, same is the voltage across the resistance. So basically we need to find out the expression for voltage across the capacitor. Again we have to solve the three steps. First one is before switching to calculate the value of voltage at the instant of switching, that is Vc0. So before switching, what we have, the switch is in position 1, that is sorry, position A. 6 volt source, 4 ohm, 2 ohm, and this capacitor will behave as open circuit. So in order to calculate the voltage across this capacitor, that is Vc0, we actually need to calculate the voltage across 2 ohm resistance since they are connected in parallel. Vc0 will be same as voltage across 2 ohm. Now in order to calculate the voltage across 2 ohm, we can apply voltage division rule. So voltage division rule suggests that voltage across 2 ohm resistance is source voltage, that is 6 into 2, the resistance across which we are finding out the voltage, and in denominator 4 plus 2, because this is the cycle. So basically 6 upon 4 plus 2 is the value of current flowing through 2 ohm resistance, and we are multiplying the current with the resistance in order to calculate the voltage. So Vc0 is actually 2 volts. Then the next step is after switching. After switching, the switch is in now position B, when it's in position B. So 2 ohm resistance is there in the circuit, 4 ohm capacitor, and then we have again 2 ohm resistance. Now in this position, since we don't have any source connected, so at t equal to infinity, the voltage across the capacitor will be 0 because we don't have any source. So all the energy which was stored up in the capacitor before switching, that will get dissipated and the voltage across it will fall to 0. So Vc infinity is actually 0. And then we need to calculate time constant tau, which is equal to R equivalent into C. R equivalent we have to calculate from the after switching conditions. 6 volt source replaced by short circuit, though it will not have any impact on the calculations of R equivalent. Then we have 2 ohm, 4 ohm, 2 ohm, and these are the capacitor terminals where we need to calculate R equivalent. Now, what is R equivalent? If any of the current will flow from here, it will get divided into two parts. It means this 2 ohm is in parallel with series combination of 2 and 4. So R equivalent is 2 in parallel with 4 plus 2. So which will give us the value of R equivalent as 3 by 2 ohm, 1.5 ohm, tau R equivalent into C. The value of C was 1, so it's 1.5 second. Now let's substitute all these values in the expression of voltage across a capacitor. Vc infinity is 0 plus Vc0 2 minus Vc infinity 0 into e raised to power minus t by tau. So Vct will be equal to e 2 into e raised to power minus 2 by 3 volts, which is same as Vt. In next video, I will solve a few more problems of RC series circuit only. If you have any doubts, you can ask me in the comment section. Thanks for watching the video.